Here we have a question where we're asked to compare an integral that we calculate geometrically using a triangle and an integral that we calculate using integrals. So the first thing we'll do is we'll calculate using a triangle. And remember, the area equals a half base times height. So if I'm looking at the line where f of x equals x minus 1, then what I'll do is I can sketch that, and it's going to look something like this. And here are my axes. So this is between 1 and 3. Here's the point at 1, 0, and here's the line at 3. We'll call that point 3, 0. But if we go up here, we get to the point, 3 and 2. So if I look at this triangle, I can say, well, the base here goes from 1 to 3, so that's got a distance of 2. And the height goes from the x-axis to a height of 2, and that's a distance of 2. So therefore, my area equals a half base times height, which equals a half of 2 times 2, which equals 2 units. And there's my solution geometrically. Now what I want you to see is that when I do a solution geometrically like this, it's often far easier than if I worry about doing it by integrals. But I can do it by integrals. So that's what I'm going to do now. Now if I look at this area using integrals, then I'll say the area is the antiderivative of f of x with respect to x between my 2 points A and B. Let's substitute everything in. So then it's between 3 and 1 of x minus 1 dx. Now, then I have to antidifferentiate. So I get the antiderivative of x will be x. Now this is to the power of 1, so I have to raise my power. So let's do it in blue because that's our thinking colour. So it'll be x to the power of 1 plus 1 over the new power minus, now 1 is x to the power of 0, so essentially x to the 0 plus 1 over 0 plus 1. We'd normally have a plus c, but that would cancel out. And so because this is a direct interval, it's between 3 and 1. So it equals x squared over 2 minus x between 3 and 1. And now I'm going to substitute my values, and I'll get 9 over 2 minus 3. That's substituting my 3's in, so the 3's become our x's there. And then from that I subtract, because it's a definite integral, I subtract 1 over 2 minus 1. And when I do that, I come up with an answer of 2 units as well. So I can do this either way, but it's always worth keeping in mind that the easier way is quite often geometrically. So when I have to find the area under a straight line, I'll normally look to solve geometrically because it is an easier way to do it, even although I get the same answer.